Sometimes they will ask problems like this. They will give some loop equations or mesh equations, and you have to derive the network for these three mesh equations. There are three mesh equations. Mesh equation for the first mesh is this, second mesh equation, third mesh equation. So there are three variables, I1, I2, I3. So you have to write matrix with 3 cross 3 matrix. I1, I2, I3 are mesh currents, and right sides are voltages. 110 mesh voltage in the mesh 1 is 110, voltage in mesh 2 is 0, voltage in mesh 3 is 115. So we have to recall the concept of the first module. So how to write KVL for this? Consider this circuit. Okay, R1, R2, R3, V1 and V2. If you write a KVL for mesh 1, you're going to get R1 plus R3, I1 minus R3, I2 is equal to V1. That is the meaning of this one is this element will be sum of resistance in mesh 1. R1 and R3 is the sum of resistance in mesh 1. Common to 1 and 2 is R3. You have to write minus. And voltage while writing this is minus to plus is the minus. If you bring it to right side, it becomes 1. Similarly, if I write KVL for mesh 2, common to 2 and 1 is minus R3, I1. And sum of resistance in mesh 2 is R2 plus R3. And writing KVL, this is plus to minus. So if you bring it to right side, it becomes minus. And we can represent equation number 1 and 2 in the form of matrix. Remember, in the matrix, first element, diagonal elements, sum of resistance in mesh 1, sum of resistance in mesh 2. And this is common to 1 and 2. This is common to 2 and 1. These are the two currents, I1 and I2. And these are the voltages in mesh 1 and mesh 2. And using Cramer's rule, you can find out I1 and I2 by replacing first column with the right side value. And original resistance matrix is this. And you have to find delta R of this circuit. And I1 is given by delta 1 by delta, and I2 is delta 2, where delta 2 is second column, should be replaced by right side value. So this now what you have to understand is this one. Okay, in the mesh equations, this one is sum of resistance in mesh 1. This is common to 1 and 2. If the third mesh is there, common to 1 and 3. If you remember that, we can solve this problem. Now consider this. This is some diagonal elements. Sum of resistance in mesh 1. 2 is sum of resistance in mesh 2. R33 is sum of resistance in mesh 3. All these are positive. Remaining are negative. I1, I2, I3 are the mesh currents. V1, V2, V3 are the voltages. Now given in this given, sum of resistance in mesh 1 is 8. Common to first mesh and second mesh is minus 5. Common to 1 and 3 is minus 1. Common 2 to 1, whatever is there, no, same thing will come here. It's the sum of resistance in mesh 2. Common to 2 and 3 is 0. And similarly, common to 3 and 1, common to 3 and 2. Sum of resistance in mesh 3 is this. And I1, I2 are the mesh currents. These are the voltages. So now you have to derive circuit elements. First, you have to write common elements first. So write three meshes, right? And it is mesh 1 is common to 1 also, 2 also. Okay, mesh 1 is common to 1 and 2, common to 1 and 3. So you have to write three boxes like this. If suppose this is 0, suppose this is 0, then you have to write mesh 3 here. No connection from mesh 1 to mesh 3, but here there is a connection from 1 to 2, there is a connection from 1 to 3 also. So this is mesh 1, mesh 2, mesh 3. So write three boxes like this. Suppose this is 0, this is 0, then you write mesh 3 here. No connection from 1 to 3, but here connection is there. So common elements you have to write first. So first you have to write common to 1 and 2. Common first step is common, this is mesh 1. Right here, I will rewrite once again. Write three boxes like this. Okay. Common to, this is 1, this is 2, this is 3. Common to 1 and 2 is what? 5. So write 5 here. Common to 1 and 3. Write 1 here. So 1 is over, 5 is over. Next, sum of resistance in mesh 1 is 8. Sum of resistance in mesh 1 is 8. How much is over? 5 is over. 5 plus 1 is 6. So remaining you have to write. From 8, you subtract 6. Then you have to write here 2. This is 8 minus 6. 5 plus 1. Next, coming to the and voltages. Voltage is plus 110. So you have to write minus here plus 110 volts. While writing KVL minus, bring it to right side means plus. Next, coming to the mesh 2. In mesh 2, no voltage. Voltage value is 0. Common to 2 and 1 is 5. Sum of resistance in mesh 2 is 12. Sum of resistance in mesh 2. Common to 2 and 3 is 0. This is short circuit means 0 resistance. So it is, you have to write here 5. Remaining it is 12 now. Sum of resistance in mesh 2 is 12. So 5 plus 7 is 12. How it is 7 means from 12 you subtract 5. Okay. 12 minus 5 is 7. And no voltage source here. Coming to mesh 3. Common to 3 and 1. 3 and 1 is 1. Common to 3 and 2. Common to 3 and 2 is 0. And sum of resistance in mesh 3 is 7. Sum of resistance in mesh 3 is 7. 1 is already there. 1 is already there. So remaining you have to put 6 here. This 7 minus common element. And there is a voltage of 115. Again it should be minus to plus. So you can write here or you can write here. You can write here. But while writing, you can write first negative, next positive. 1 minus plus. While writing KVL, minus plus is also minus plus. So this is the answer. So we derived this circuit element circuit. We draw the circuit diagram from this mesh equations. Next, let us do one more important problem in the next problem.